Hi guys, my name is Vivek and in this video tutorial we are going to talk about partitioning in Oracle. As we have done in our previous videos, we are going to learn this with the help of multiple scenarios from different domains. I'm going to use the example from financial domain, retail, insurance, just to make sure that by the time we end this series, you will be able to identify the contenders of partitions in your project and you can implement it successfully in your projects. So without doing any further delay, let's go ahead and understand what is partitioning. So this is the standard definition that you will find on Oracle website, which is kind of self-explanatory. Let's go over it real quick and then we will understand this will be with the help of a real scenario. So it says partitioning allows tables, indexes and index organized tables to be subdivided into smaller pieces, enabling these database objects to be managed and accessed at a final level of granularity. Now what does this mean? Let's understand this definition with the help of an example. So I am the data warehouse manager of a financial institution of a bank that is operating in all the three regions. That means it's operating in Asia Pacific, Europe, EMEA, and it's operating in North America as well. So I'm getting billions. I have 400 million customers in my bank and I'm getting billions of rows on a daily basis or on a monthly basis. Now let's see the data real quick. So we have data coming from, we have this transaction table that has 6 columns. It has the transaction ID, the customer who has done the transaction, what's the amount that's been used, whether it's being credited or debited, what's the date of the transaction, and in which region the transaction has been performed. So obviously this is the subset of the data. We have billions of the rows in the table. Now let's understand the scenario that we have at our hand and we will see how partitioning can help in that particular scenario. So as a manager, I want to retrieve the details of all the customers from EMEA region. So when we are talking about this many data, which is almost 30% of the data, in that case indexing is ineffective. So indexing, it actually is useful when we are using 5 to 10% of the data or when we are retrieving 5 to 10% of the data. Beyond that, for the Oracle Optimizer, it goes for the full table scan. But when we have such huge amount of data, billions of rows, then both indexing and full table scan, they will take way too much time and they will be ineffective. In that case, what's the solution? The solution is partitioning, and we will see in a moment how it's effective. So what I'm going to do is I'm going to partition this transaction table on the basis of region, and we will see what will happen when I create that partition in a moment. So when I created the partition, or I partitioned my table with region, what happened is it created 3 different storage space, and these are called segments. For each partition, it created different segments. That means there is a clear differentiation where the data is being stored based on the region. And what does that mean? This means on my database, on my storage, on my disk, I will have the data corresponding to Asia Pacific stored in a different area, EMEA in a different segment, and North America on a different segment. So there is a clear differentiation. We cannot have, now that I have unambiguously defined that, okay, region is my partition key for this particular table, it will allocate different segments for different region and there will be a clear differentiation. AP will be in a specific segment, EMEA in a specific, and North America in one. Now when I want to retrieve the entire data for EMEA segment, I don't have to go for the full partition scan. It already knows that, okay, the EMEA data belongs in a particular segment. It's going to do a full partition scan, which is much faster because it's going to access less amount of data, and we will get the data for the EMEA. So it's still going to do instead of doing a full table scan, which would have included our North America and Asia Pacific region, if you see the explain plan, it's going to say full table scan, but for that particular partition. And this particular concept is called partition pruning. So if you see, as soon as we partitioned the table, our performance significantly improved. So the first reason behind partitioning is improvement of performance when handling huge amount of data. So any table that is bigger than 2 GB may be a possible contender for partitioning. Now let's go ahead and see advantages. So I have another transaction table. I mean, this is a different transaction table. It's being laid out in a different manner. Here we have the 6 columns. We have transaction ID, customer ID, amount, type, and year being the critical column here. So we have data from 2015, 2016 and 2017 for these 3 regions. Now the use cases or the business cases that I want to keep rolling 3 years of data in my transaction table. That means as soon as I will enter 2018, I don't care about the data from 2015. All I care about is the data from 2016, 2017 and 2018. That means on 1st January 2018, I'm going to delete all the data from 2015. Now let's see how that's going to happen for a table with billion of rows. So on 1st January 2018, I'm going to delete all the 2015 rows. Now it's a DML operation and that's going to take forever. If you want to delete billions of rows, even with an index in a huge table, trust me guys, it's going to take a lot of time. So what's the second option that we have here? If we partition our table using year column, then the delete can be instant, almost instant. Obviously there are certain constraints. I don't want to explain them at this point of time, but it's a DDL operation. You're going to alter the table and you're going to drop that particular partition. So the data which is uniquely stored, I mean, there is a clear differentiation. As I mentioned earlier, those data are stored in different segments for the year 2016 and 2017. So the Oracle optimizer will know the locations where it's being stored, which is exclusive from the data for 2016 and 17. It will know that, okay, all the 2015 data is stored at this particular row. Just go ahead and drop the data. So if the table is partitioned and you have to maintain rolling year of data, you can do that pretty quickly with the help of partitioning. So this is another thing where partition pruning helped us. And if we revisit the definition of partitioning in Oracle, we will see that it allows tables, index and IoTs to be subdivided into smaller pieces. So that's what we did. We subdivided our tables into smaller pieces. And what did it mean when it said final level of granularity? So in our first case, we used region to divide these tables. That means earlier the grain was transaction ID. Now along with that, we have region as well as the grain. So all the data pertaining to a particular region is stored separately. And if we see this, that's what it says, that we can subdivide our data into smaller pieces and these database objects can be managed and accessed at a final level of granularity. So in our first table, we did segment or we did divide them on the basis of the region, and in the second case where we had to maintain rolling 3 years of data, we used partition on the column year. Now let's go ahead and understand another use case. I have a transaction table where I'm keeping rolling monthly data. That means, say right now I'm in May 2017. So I only care about data from January, February, March, April and May. I don't care about the data from the other years. In fact, that doesn't even persist. And the other thing is that only the new data from May is editable. Rest of the data is read only. So if you think of it, you can only do transactions for the current month. You cannot go back in January, or you cannot go back in time and change something, right? If you have to credit or debit, it has to be done for this month. So for the previous month, the data is read only, while for the current month, you can insert the data, you can delete the data, or that kind of stuff. Now, if you partition the table on this particular column on the month, what will happen? It will be very easy to manage for the DBA. So we are maintaining the rolling months of data for the current fiscal year. Previous months data are read only. Only current months can have insert, update or delete. Now if you have to backup or restores, you don't have to do that on a regular basis for the previous months because they are already stagnant. There is no change to that. So imagine the amount of space. If you have to save your production data on a daily basis, you don't have to save the previous 11 partitions. The only partition you have to save is, or update is, the partition for the current month. So you are saving space on your storage drive. At the same time, the important factor is the backup is going to take very less time, and the data, in case there is a failure, in case the drive crashes, to get the data back from SAN to your database, that time is going to be low, and which is very crucial. So since you are able to independently manage partition, you are able to reduce the timing in case of backup and restore. So the first thing that partition gave us was improvement in performance. The second thing is data manageability. You can save the space, and the backup and restore is very faster. So that's the second thing. And guys, it may seem like a small thing to you, but imagine when you have such a huge system that has billions of rows, and we are talking about terabytes of data, that backup can take almost an entire night. It can take 12 hours or more than that. And in case, if God forbid, your system crash, the restore is going to take a lot of time if you have not partitioned your data correctly. So it's very vital. A very large database cannot run efficiently if your tables are not partitioned in the correct manner. So it's a vital concept, and I will try, as we progress, I will try to give you more examples so that you can actually visualize the importance. But as of now, we have discussed two things. The first thing is performance, and the second thing is manageability. Let's move to the third important aspect with this scenario. So again, we went back to our transaction table that was partitioned by region. So we have data from Asia Pacific, EMEA and NA. Now, and this has billions of rows, guys. So now the scenario is that the Asia Pacific day has started. That means it's morning in India, China, all those countries, and the North America day has ended. That means in United States, Mexico, Canada, all these countries, it's night. So that means not many people are working on the data of North America region, while majority of the business analysts from Asia Pacific region are up and working. Now we have a problem. The NA partition is unavailable. There is an issue with the partition, it's unavailable. The transaction table, obviously we store the data on the database on different storage racks. So where the NA data is being stored, that storage has some electricity issue or some other issue, and that particular partition is unavailable. If the table was not partitioned, your system would have went down. You will not be able to perform any operation if the table is not partitioned, because the storage racks on which a part of your transaction data is being stored, that is unavailable. But if your transaction table is being partitioned on region, even though the NA partition is unavailable, you can still go ahead and continue to perform your AP operations, as long as you don't try to access data that belongs to NA partition. And since our data is being divided into 3 or more partitions, the DBA, he can independently restore the NA partition, and it will avoid significant downtime, as well as it's going to be very quick. Obviously we have huge amount of data, so quick is a relative term, but still it will be quicker than restoring the entire table. So let's quickly recap the advantages. The first thing is performance. So I explained what is partition pruning. When we wanted only the EMEA data, it actually ignored the data from Asia Pacific and North America. And there is something called partition voice joins. As we progress in this video series, I'll explain both of them with different examples and it will be clear to you. Then we have manageability. So when Oracle actually introduced this partitioning concept in 8i, it actually was thinking about divide and conquer approach. And if you see, the definition itself says that we are dividing some objects into smaller objects that can be independently managed. So we are dividing the objects and we are easily managing them. So Oracle was thinking divide and conquer approach when it actually went with partitioning. It gives us faster backup and restore, because now you have to back up a subset of data and restore a subset of data, and since you are doing that, you're using low storage on your SAN. And then we understood availability with the example of North America and Asia Pacific region. The North America disk was unavailable, still we were able to pursue our operations in Asia Pacific, and the DBA, he could independently restore the NA partition data. If you have worked on a real project, you will know that every week or month you have scheduled maintenance where they will restart the server or they will back up the data, that kind of stuff. So with partitioning of huge objects, that process is very faster and your scheduled downtime is significantly low, because now you can independently process data in parallel. So these are the main advantages why we require partitioning. And believe me guys, if you have a database that's in terabytes or more than that, you definitely need partitioning, at least on certain tables, or there is a good chance you already have partition tables existing. And hopefully by the time we end this series, you will be able to understand that those partitions or those partition tables, and if you don't have them in your database, you will be able to suggest it that alright, you know what, we can create partitions on these tables and this should be our strategy. So as a part of this series, what exactly are we going to discuss? So these are the contents that we are going to discuss. We are going to discuss the performance basics. Then there is another storage area which I find vital. What are blocks, what is an extent, and what is segment? Oracle stores block is the basic building unit, and what is extent, what is segment, I will explain all that in my next tutorial. Then I'm going to explain what is single block and what is multi-block read. Why in some cases actually full table scan is efficient than using index. So I'm going to explain that, index versus full table scan. When exactly we should partition a table index or an indexed organized table. What do we mean when we talk about the partitioning key? And we are going to again understand we are going to relive the advantages using different examples from different domains. So right now we discussed transaction table from a financial institution. Maybe in the next concept I'm going to take a retail organization and I'm going to help you understand that why partitioning is important in retail as well. Then I'm going to explain the different types of partitioning, the single partitioning and composite partitioning, and I'm going to again explain this with real examples from different domain. We have list partition, range partition, and hash partitioning strategy. These are the three strategies, and using these strategies with each other, we have something called composite partitioning. I'll explain in which cases this is relevant and that kind of stuff. Then we have something called interval partitioning versus range partitioning. What are the difference? And then we have something called reference partitioning. When we have parent-child relationship, how do we create partitions? That kind of stuff will be discussed when we are talking about this. Then we will talk about how do we partition index, what are local and global index, and when we draw partitions, what are the challenges. And as we gradually progress, I will also tell that what are the limitations with Oracle 11g. I hope that at least all of you are on 11g right now, and what are the additional advantages or features that are being offered with Oracle 12c. Hopefully this was a good start to get you kicked off with the partitioning in Oracle. And if there are some things that you could not understand, I would recommend that hold on, we have quite a few videos coming on the same thing, and I'm going to repeat these concepts, and as you go through them with different scenarios from different backgrounds, you will be able to relate more. I'm actually very excited about this. Hopefully in my next session you will join me again to understand the performance basics and types of partitioning. I know this has been a slightly long tutorial, so we are going to call it a night right now. But if you did like this tutorial, I will recommend that you subscribe to my channel, so as soon as I upload the next tutorial you are able to see it. And guys, if you have any questions, please do drop them in comment and I'll try to reply as many of them as soon as possible. Thanks a lot guys for watching these videos, and I'll again ask, please do subscribe to my channel.